Alright, so today what we're going to do is we're going to talk about the last assignment, new assignment that you're going to be getting this semester. Sorry about that. So this is where we're going to use coordinate geometry to prove that a quadrilateral is a parallelogram. Now, we studied way back in the old world before pandemic. We discussed how to prove that a quadrilateral is a parallelogram. And 4 of those methods we can actually use coordinate geometry, which for those of you who hate geometry and love algebra, this is good news because our focus is really on the algebra part of things. So what we're going to do is we're going to talk about these 4 different methods. And what I'm going to do is I'm going to kind of show you what it looks like as a flow chart, because you will have to be able to do this as a flow chart. Now, this very first problem here talks about using the distance formula, but really what the easiest way that my students have found to do this is to use the Pythagorean theorem. So let me kind of show you a little bit of what we're talking about here. The first step is to graph the parallelogram. So we have A is at -1, 6. B is at 3, 5. C is at 5, -3. Apologize for the cat. And D is at 1, -2. That's wrong. Five, -3, 1, -2. Well, maybe it isn't wrong. I just looked wrong. And so now we're going to connect the dots. Should use a ruler. And so now we have this parallelogram. In order, sorry, I have a cat in my lap. Wanting to be on my lap, that is. Say hi, Ticker. Okay. So in order to be able to solve this problem, our real task is to find the length of each of these 4 sides to this quadrilateral. Now, we know it's a parallelogram, but we're trying to prove it's a parallelogram. So in order to prove it's a parallelogram, we actually have to calculate all 4 lengths. You can't calculate this and say, aha, it's a parallelogram, so I don't need to calculate this one. Because the whole point is to prove it. So what we're going to do is we're going to focus on right triangles, because that's really what's going on here. If I draw a right triangle, connect and make this side of the parallelogram the hypotenuse, then I know this length right here is 2 units. This length is 8 units. And the length of AD, that value squared, that's the hypotenuse squared, is equal to the lengths of the 2 sides squared and added together. 2 squared is 4. 8 squared is 64. When I add those together, I get 68. That's AD squared. And so then I'm going to take the square root of both sides, and because all we're trying to do is prove they're the same length, we don't actually have to do any further calculations. We know that AD or DA is the square root of 68, because we're going to compare this one with the other side, which is BC. If those 2 numbers are the same, and if these 2 numbers are the same, then we know it's a parallelogram. So now what I'm going to do is I'm going to do the same thing over here. I see that this is 8 units, this is 2 units. So for BC, it's 2 squared plus 8 squared. At this point, it would be absurd to have to actually write out this step because you already know that if these match, this is going to equal 68, and then you take the square root of both sides. And so now we've proven that BC here equals the square root of 68. So now I have these two. Now, just having two sides that are congruent does not mean all four sides are congruent. Isosceles trapezoid has one pair of sides that is congruent. The other pair of sides is parallel. All right. So now what I want to do is the other side. So I'm going to go ahead and do DC. And when I've done that, DC squared is going to equal the sum of the squares of these two sides, which is 1 squared plus 4 squared. And then I'm going to get a value for the length of DC or CD. Do the same thing up here. And as long as these two have the exact same value, then I can say, and this kind of goes back up to this reason up here at the top, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So I would be able to say here, because AB equals CD, and AD equals DC, we know both pairs of opposite sides are congruent, which proves that ABCD is a parallelogram. Now, I'm not going to keep doing all of this because you have to actually do some of this. This is 1 out of 6 problems that you have to do. Now, the first 4, I'm walking you through the steps of proving that it's a parallelogram. There are, like I said, 4 methods. The last 2 problems, you have to choose your favorite method for one of them and your second favorite method for the other. Because on your test, you don't have to use a particular method. You can use any one of these 4 methods, but you will have to be able to prove it's a parallelogram. And you will have to be able to calculate the distance or the length of a line segment. You will have to be able to calculate midpoint and slope. And on the very last page of your assignment, there is a summary page that talks about these different methods and that walks through the steps of using the different formulas. Now, this one is my favorite method. When we graph the parallelogram, one thing that we can do is we can discover, are the midpoints of the 2 diagonals, now here's the diagonals, if the midpoint of the 2 diagonals is identical, then we know it's a parallelogram. So we would use the midpoint formula, which I've given you here. And if these 2 midpoints are the exact same thing, then we would basically say down here, because the midpoint of AC is equal to the midpoint of BD, we know that each diagonal bisects the other. Therefore, it is a parallelogram. So in each of these on your homework, on your assignment, it has a bit of an explanation. It has the formula. It gives you a graph to graph it. Now, I know that some of you have had troubles with this. I'm going to try to make sure that on your next test, you won't have to worry about graphing a quadrilateral. You will have the opportunity to use, I'm going to try to make sure that it's going to be provided for you in one way or another. Okay? So we've talked about problem number 2 here. Problem number 3. This is where we're proving it's a parallelogram based on the definition of a parallelogram, which is a quadrilateral where both pairs of opposite sides are parallel. And so in order to prove this, we have to prove that the opposite sides are parallel. And the easiest way to do that is to calculate the slope of each side. And we can do that using rise over run. For example, if I wanted to find the slope of this side, my rise, I'm really going down 8, so that's -8. My run is 2. -8 over 2 would be the slope of this line. And again, it doesn't matter about simplifying because we're just comparing two values. So I would find the slope of this and the slope of this, see if they're the same, slope of that and slope of that, see if they're the same, and if they are, I would probably, my conclusion would probably be, because the slope of AB is equal to the slope of CD, or whatever, and because the other two sets of slopes are the same, that proves that those line segments are parallel, and by definition, a quadrilateral with both pairs of opposite sides parallel is a parallelogram. So then I would be able to prove it. And I would put the values here, and then my conclusion here. So make sure you show your work, graph, etc., etc. Now, sorry, I have a really bad case of the yawns this morning. It's probably because it's not even 5 a.m. All right, and then the final one is where we graph the parallelogram, and we want to choose one pair of opposite sides. We want to prove that this pair of opposite sides is both parallel by finding the slope and congruent by finding the length, and then we can say it's a parallelogram. Now don't forget that there is some help available on the very last page of the entire assignment. So make sure you scroll there and you'll be able to find that information.